Good afternoon, students. Today we will be discussing about analog write and digital write, which is used by Arduino Uno for facilitating input and output. So, if we go by with our discussion here in Module 2, Lesson 5, Arduino I/O functions. When we say I/O, it actually means input output. So, in order for our Arduino Uno to function correctly, it needs first an input, then an output. So input is anything from signals, analog or digital, that the Arduino Uno will receive in order to create a program. So we also have what we call outputs. Outputs are what the Arduino Uno is able to give you based on the inputs that he is receiving or it is receiving. So, pins can be either configured as input or output depending on the situation or how you actually use it. So, I want you to open Tinkercad. I want you to open Tinkercad and create a new circuit here. So, click circuits, then create new circuit. So, we will be trying to recreate whatever is you can see on your screen at the moment. As you can see, there is a pulsating green light, right? So let me turn off the light of my room for a bit so that you can see more clearly what currently is being shown. Okay. So now, I want you to prepare the materials that we are going to need for our um, demonstration here in Tinkercad. So I want you to pull up a small breadboard, the Arduino Uno, three kinds of LEDs of differing colors. Um, the colors is up to you, but for this I will be using red, green, and blue. So now that I have red, green, and blue LEDs with me, next we are going to be needing an RGB LED. So let's just search LED, then a LED RGB will show up. So now we have everything we need with exception to with the jumper wires and resistors. So then we are going to look for the resistor, which is usually shown here in the basic components. What we're going to need is a 220 ohm resistor. So choose ohm, then type 220. So now we can try to recreate how traffic lights are being simulated. We're going to simulate our own traffic light. So, what are the major colors being used in traffic lights? This is yellow, green, and red. So maybe this blue one, we are going to change this to yellow. So let's just replace this with yellow. So now that we have green, green, red, and yellow, let's align this in order. Let's put red here, then let's put yellow here, then green. Then we're going to need this 220 ohm resistor, one for each. So you can simply copy and paste it to replicate or duplicate the resistor. Let's use this.
Excuse me, sir.
Yes.
Code lang ang makita namin, sir.
Okay. Thank you for your input. So here, I hopefully you can see the demonstration now, right?
Yes po.
Okay. Now that you can see it, require you to include three LED bulbs here and a single resistor. You can basically replicate the resistor by copy pasting it. So it would be no problem you have uh, if you have a single resistor taken. This should be 220 ohms resistor and a LED or RGB LED. You can search this by searching LED, then it should be appear here with four legs, LED RGB. So now I'm going to align the RGB LED here in the order of red, yellow, and green. Red, yellow, and green to simulate uh, go, then ready, then stop, ready, and go. Now we are going to add resistors for each so that it will function correctly or it won't have to deal with overloading issues. So we need resistors for this. So we are going to attach. You will notice that one is bent and the other one is straight. So I want you to add a resistor in the straight side and put it here so that it connects with this ground or negative pin out or negative socket. Do this for the three LED bulbs. Let me move this a bit there. Now that we have three resistors here, I want you to add ground wire to the black space that we assigned earlier. There. Then let's try changing the wire to color black. Click the wire, then change the color to black so that it aligns with the coloring. Next one is to add wires to each of the legs or the remaining legs of the light emitting diodes. So here, then let's connect it to pin 4. Leave the color as color green. Then the other leg for the yellow, put it in pin 3. Let's change the wire color to yellow to match the bulb color. Then let's assign this to red for pin 2. Again, green should be connected to 4. Yellow should be connected to green to number 3. And red should be connected to number 2. We will change this color to red. Okay. So now we should have a LED that is actually that should function similarly to traffic light, with exception that it has no code present in it. So I want you to open here, click code. So we won't be needing this code blocks. Instead, I want you to click blocks here and click text. Again, click code, then in the drop down of blocks, choose text. So let's move the screen here for a bit so that you can see the actual wiring there. Now that we have pins for each color, maybe we can change it a bit. So above void setup, you will notice there's a void setup here. I want you to press enter maybe 5 times. 1, 2, 3, 4, 5. Now we have opened up few spaces here above, right? I want you to declare a variable. I want you to declare a variable. So to declare a variable, I want you to type int, then the name of your variable. Let's say, uh, let's type maybe uh, green. Then equals or assignment operator, then what pin it belongs to. So for green, we have connected it to pin 4, right? So let's type 4 here. Then semicolon. Then we are going to repeat this for the other LED bulbs. Int yellow is equals to 3 semicolon, then enter again. Then int red is equals to 2 semicolon. I hope you are following. Then now we are going to change this pin mode. You will notice there is a pin mode 13 and output here. I want you to change this to the one that we have declared above. So first, we are going to remove the number 13 and change it to the color. So let's say green. I want you to copy this line and repeat it for yellow and red. So let's do this for yellow and for red as well. So now, in void setup, we are declaring the pin mode so as to turn on the pins for future usage. We are turning on the pins here so that to notify the Arduino that we are going to use the specific pins in this number, which is 4, 3, and 2. So again, this is 4, 3, and 2. Now, if we're going to remove these comments here, just to lessen the clutter, you will notice there is a code called digital write 13 high, then digital write 13 low. If you're going to read this, it actually means we are going to turn on whatever is in pin 13. High means on, low means off. So it actually makes whatever is in pin 13 on and off. As you notice, there is nothing in pin 13. So we will be changing it with the pin that we are actually using, which is green, yellow, and red, or 4, 3, and 2. So now we are going to change 13 to the color, which is green. Then do this for red and yellow as well. Yellow, then red. This means green, yellow, and red should turn on together. Then we notice there is a line called delay. Delay means uh, how much time it takes before it moves on to the next command. So, for example here, delay 1000. The unit here is milliseconds. So, this 1000 here denotes that it is 1000 milliseconds or equivalent to 1 second. So now, we're going to redo what we did earlier, but now in low. Green, yellow, and red. So, low, low, low. So now we have high and low. Let's try running the code. Let's see if it actually turns on. As you notice, it is turning on and off, right? It means we are successful in turning this on. Again, when we say digital write, we are actually trying to put an output that is only two types. When we say digital signal, there's only two types of digital signal, right? It's either on or off, zero or one, high or low. So maybe we can simulate how traffic lights work. Let's say green should turn on for 5 seconds. So we can make this 5 seconds. It will turn on green for 5 seconds, then yellow for 1 second, yellow for 1 second, then red for another 5 seconds. Of course, we are going to turn off the lights if it turns on another. So when the yellow starts to turn on, we should also add the code here that allows the green to turn off. So when yellow starts turning on, the green should turn off. Then same for yellow. Yellow here should turn off. Then red should turn on. Then maybe yellow should turn on again for 1 second only. Maybe let's turn off red first. Then turn on green. Okay, let's check our code. Let's add a turn off function for yellow here. So yellow should turn off. Let's see. This should alternate here. Green for 5 seconds, then yellow for 1 second, then red for 5 seconds, then yellow again, then back to green. So that's how digital write works. It's either on or off. The delay dictates how long we are running the code. Now, let's move on with analog write. So I have discussed in our previous lesson before that analog write allows us to simulate analog signals, which is not one, neither zero. It could be somewhere in between or could not be or could be beyond zeros or ones. For example, it could have a value of 1.5, it could be a value of 2, it could be even -5. So it could be possible using what we call pulse width modulation. So PWM or pulse width modulation here can only be used in pins that actually has the tilde or this curly wave here, which is pin 3, 5, 6, 9, 10, and 11. So for this one, we will be using 9, 10, and 11. So let's use 9, 10, 11, and 11. So we are going to disable this code first because we are not going to use this traffic light simulator anymore. You can easily disable the code by typing double slash in it at the beginning of each code or line of code. So double slash, let's stop the simulation first and type double slash. Now, when it shows up in brown, it means it is currently disabled. We are making it as a comment so that it is not usable as a code. So now that we have disabled the code, when we try to run it, it should not turn on or off. As you can see, it is neither turning on or turning off. Now, we are going to make use of the RGB LED that we have. So, this is how RGB LEDs look like in real life. So, let me zoom this in. Let me focus the camera. Wait, let me just uh here. Let me just focus camera a bit. Mm-hmm. You can see where the camera is. There. So this here is what we call an RGB LED. As you notice, it has four pins in it. Three of those are the three primary colors, which is red, green, and blue, and the other one is used as a common. So we have here uh, an RGB LED. So you can find it here if you search LED, then it should show up here. Now, want you to add this here, somewhere here. Then, orient yourselves with each of the colors here. So this is red, this is blue, this is green. You should take note of that. You should try to uh, maybe recall it. So let's try moving this here up a bit. Try moving the LED bulb here. Then I want you to copy the three uh, resistors here. We can even use of it. We can use it. So we can easily drag it. So red needs a resistor, then blue, then green. The other leg which is used as a common should not have any resistor. So I want you to add a pin here that connects directly to the ground. Okay, then color it black. Now, I want you to connect each of these colors to the PWMs 11 to 9. So let's say red should be pin 11 and assign it red color. Then this one is blue, which is in pin 10. Then lastly, oops, I think I might have added the wrong one. Green, which is in pin 9. So now we have the three colors uh, currently inserted in our Arduino. So let's go to the code. Now that we are in code, uh, I want you to again uh, declare the variables on it. So maybe we can remove this one because we are not using green, yellow, and red anymore, and instead redo it. Let's say int pin red. So pin red is in 11, int pin blue is in pin 10, and pin green is in pin 9. Now we are going to change the void setup again to accommodate to the changes. So let's say this one pin green, pin blue, and pin red. Now, let's just remove this code here, or maybe we can ignore it. Now, we are going to create analog write. So first type analog write, similar to how digital write is written, analog write, capital W, then parentheses, then semicolon. So inside it should be the color that you want to modify and the value in which you are going to turn on or off. So the limit for the value should be 0 to 255. So maximum is 255, which means uh, high. 0 means low. So as you might have noticed, there are different middle values in this. So let's try modifying pin or red pin. So pin red, then let's try recreating maybe fade in and fade out effect using the red. So let's say let's start with 20 or maybe 25. Then let's add a delay, a very short delay. Delay 100. Then let's do this until we uh, reach until maybe 200. Then 50. Then 75. Then 100. 125. 150. Then 175. Lastly, 200. So let's check how it would look like using our code. Let's try running this code. As you notice, it is fading in and fading out. If you want to see this in its actual form, maybe we can try simulating it in our actual Arduino here, which is, as you can see, it actually is here. Let's try copying the code here and paste it in this side. And let's see what happens to uh, this one. Okay, the color is wrong. Maybe what pin is this? Pin red is blue. Let's just say, let me test the colors a bit. Green is, this should be 9. Let's try pin green. So green is correct. So uh, the values are just interchanged. So let's say like that. Okay, let's try running this again. As you notice, it is glowing in red, right? There might be some uh, maladjustments here. That's why it's bleeding green. But as you can see, it is, or rather, let's change this back to red, I guess. As you can see, it is fading in constantly, right? Now, let's try doing it in reverse. So, we are going to reverse this. So, let's type it backwards. So, starting from 200, then 175, then 150, so on and so forth. I want you to do this until we reach 25. 100, then 75, then 50. Let me just adjust the size a bit. Okay. Now, let's try rerunning the code again. As you notice, it is fading in and fading out. So that's how uh, most of our RGB systems in our homes, specifically lights, uh, fading in and fading out work. You can even mix in with other colors. Let's say we are going to make this go together with green. So let's start the simulation a bit and maybe uh, color it with green together. Color it together with green. So let's just say green. Let's just modify this to uh, color green. Change this to green. Okay, green, 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 green. Okay, with that, I think maybe change also the value how it changes its colors. Maybe 500, then 100, then 150, then 200, 250, 200, then 150. And lastly, 100. Okay, let's check. As you can see, it changes colors depending on the how it looks like. Uh, Now, we're going to apply this code in our actually programmed demonstration here. Let's just say this is 100, then 150, 200, 150, back to 200, 150, 100. Okay, let's test. So, as you notice, it changes from green to yellow, and the red is overpowered because of how the highs and lows of greens change. So, if we run this simultaneously with this, it is corresponding with the colors here. So, I guess that summarizes our lesson for today, which is about analog right and digital right.